Okay, good afternoon everybody. My name is Carlos Reaño from the Technical University of Valencia, and in this presentation we are going to see how to really deploy the rCUDA framework. Fede, my colleague, has before commented some theoretical results, but now we are trying to learn how to really use it. So right now you already know what is rCUDA. So with CUDA we have just one node, one GPU, and we are accelerating applications running in node 1 by a local GPU. What we are going to do now is we are going to run applications in node 2, and we are going to accelerate those applications using a remote GPU located in a different node. So in order to install and use rCUDA, you just need to go to our website, rCUDA.net. You just fill a software request form, and then you will receive the package. Once you receive the package, you just download it, you just decompress it, and you have different folders. And in order to install, you just need to copy the package in all the nodes of the network you want to use rCUDA. So it's really easy. So once we have rCUDA installed in the system, first of all, we need to run to start the rCUDA server. The rCUDA server is like a daemon which is running in the nodes which actually have a GPU. So in order to run the rCUDA server, it's like if you were running a regular CUDA program. So you need to export the path to the CUDA binaries, you need to export the path to the CUDA libraries, and then you just need to start the rCUDA server. So I'm going to do this right now. Let me know if you could see everything properly. I think so. So we are going just to connect to a node in a cluster. So this node has a GPU we are going to see right now. Okay, it has a Tesla K40. Okay, so we are going to do just like that. We are going to export. This is the path where we have the rCUDA software. In this case, we have a shared file system. So it's a file system which is shared among all the nodes in the cluster. So we are going to export the variable path to this path. Next, we are going to use, in the first instance, we are going to use the TCP protocol in order to move the data through the network. And now we need to go to the path where the binaries are, in this case, this one. So you see, it works me that I'm doing it wrongly. Okay, so now we start the server, and the server is started. What does mean? This means that this node, which has an NVIDIA GPU, can now accept requests from other rCUDA clients. Okay, so what I need then to do in the rCUDA clients. Okay, so let's continue the presentation. So once I have the server, in order to run a CUDA application, instead of using CUDA libraries, I need to link against rCUDA libraries. Why? Because rCUDA libraries are going to intercept all the calls to the CUDA to the GPU and forward them through the network to the remote GPU. Okay, so instead of using the path to the CUDA libraries, we need to link against the rCUDA libraries. Next, what I need to do is to tell rCUDA how many remote GPUs I'm going to use. For instance, in this case, I will have access to one remote GPU. So we have to set an environment variable which is called rCUDA device count, and in this case we tell just one. And then where is this remote GPU? For instance, in this case, we have that our CUDA device 0 is in, we need to tell the remote server name or the IP address or whatever. Moreover, we can also indicate if this server has more than one GPU, we can indicate if we are going to use the GPU 0, the GPU 1, etc. Okay, this is important. So I told you that we need to intercept the libraries at the execution time. In order to do this, we need to compile the CUDA applications with dynamic linking. This can be done by adding a flag which is, to the NVIDIA CUDA compiler, which is called CUDA RT equals cert. Okay? And then we can just run the programs as usual. So let's try to do it again. So we are going to leave the server like this. And now I'm going to open another terminal. I'm going to connect to another node. So here, okay, I'm going to add the path to the libraries of our CUDA. I'm going to tell that I want to use our CUDA protocol TCP. Next, I need to say how many CUDA devices I have. So I have one device, and where is this device? In this case, it's in a node called like this. Okay, so now we can go to a sample which is called device query, which just queries the devices in the system. So hopefully, okay, so here we have the result of this program, which just tells us that we have one CUDA device, and if we move to the server, we see that we have received here the calls submitted by the client. So if you remember, we are talking about remote GPU virtualization. Okay, so here we have seen that we have used a remote GPU. But where is actually the virtualization? So this is one thing that could be easily done. You remember that I have said we have one GPU, okay? And the remote node only have one GPU. Imagine instead I say I have 4 GPUs. You see this, no? I just change, CUDA device count is now 4. And now I need to say, okay, my device 0 is still in 1. My device 1 is the same one. I'm virtualizing it. My device 2 is the same. And the 4 device is the same. Okay? So now, you see, I only have one physical device, but I'm using it like if I have 4 devices. Okay? So now we have both. We have remote GPU, and we have virtualized that remote GPU, and it's like if we have 4 virtual GPUs. And you see, it was really easy, just changing a couple of environment variables. Okay, so what about performance? For instance, let's run a simple bandwidth test. Now we are going to move data from the host memory to the remote GPU memory. Remember, we are using the TCP protocol. So as this takes a little, I'm going to do the same with CUDA. And we are going to compare the performance. In this case, I'm going to use CUDA, not rCUDA, in order to later compare the performance. Okay, so we have with CUDA like 10 gigs. Okay, and we see this is the results for our CUDA. It has finished now. So we only have over 100 megabytes. So here we have a problem. No? We have very low bandwidth. So the problem here is that, as I told you, we were using TCP, and we know that TCP is a low network. But we are in an HPC environment. We probably have an HPC network, and we want to run HPC applications. So let's try to use an HPC network, like, for instance, InfiniBand network. What should I do in order to use InfiniBand in our CUDA? You remember we have set a variable with TCP. Now we just need to change it to IB. So we just need to tell the protocol now is IB. So let's try to do this. So we are going to stop this server. We are just going to tell now the protocol is InfiniBand. And we are going to run again the server. So you see, now we are using InfiniBand communications. This is in the server side. In the client side, again, we do the same. We just need to tell that the protocol now is InfiniBand. We just run the test again. And you see, the performance now is much more better. We are using now a remote GPU, okay? So now we have a performance similar to that of a local GPU, okay? So now that we have a good performance, how can we take benefit from our CUDA? So here I'm just going to show you some simple scenarios. So the typical scenario when using CUDA applications, we are not always moving data. Probably we are going to move data and perform a lot of computations in order to compensate having moved that data. This is good for our CUDA because the more time we spend doing computations, this helps to compensate the extra time of moving data through the network. So in this case, we are going to test an application which is called Magma, and we are going to compare the bandwidth with CUDA. So this is a test of the Magma library, which is open source and you can download. Let me check. I think it's Cholesky factorization. Okay. You see here in the server we are receiving all the requests, and you see here, so we have gigaflops. Okay, let's take in mind this result. This is with a remote GPU. we are going to do the same with a local GPU in order to compare the results. So now this is the same test, but using a local GPU. So you see with a local GPU we have over 900 gigaflops, and with rCUDA and a remote GPU we have also near 900, so the performance is quite good. But this is comparing GPU against GPU. Okay. But probably if I'm using a remote GPU, it's because I don't have a local GPU. So probably a fair comparison will be comparing the results running the job in the CPU with the results running the job with a remote GPU. So in this case, this benchmark also shows the CPU gigaflops, which are 150 or 160. So it's much more better to use a remote GPU. And then you can even wonder, okay, what if I don't have InfiniBand? What if I only have TCP? It is worth to use a remote GPU, or it is better to use the local CPU. So we can, for this, run the same experiment, but using the TCP protocol in order to see. So we are running the same, but using TCP. As you could see, it's much slower, but let's see if it's better than using a CPU. So with the CPU, we have, again, 160 gigaflops per second, and with our remote GPU, even using TCP, 1 gigabit Ethernet, we have over 300 gigaflops. So it's worth even using a remote GPU, even if we are using a TCP network for this scenario. Okay, another more appealing scenario. So imagine that now we have access to all the remote GPUs in our cluster. So we probably have more than one node in the cluster, and we probably have more than one GPU in the cluster. Thanks to rCUDA now, we can use all the GPUs, all the remote GPUs in the cluster. So what we are going to do now, we are going to run an application. First, we will run an application in CUDA using all the GPUs in one node, and then we will run an application using rCUDA and using all the GPUs in different nodes of the cluster. So in order to do this, we just do the same as before. You remember before I explained you how to virtualize a remote GPU. So now we are going to, instead of virtualizing the same remote GPU, I'm going to use different remote GPUs. For that, again, I just say, okay, how many remote GPUs I have? In that case, 5. Okay, remote GPU 0 is in node 1, remote GPU 2 is in node 2, and so on. Okay, so let's try to see how an example for this. For this, I have just a script which just start the servers in the different nodes. In the same manner you have seen, I have started one server, so it starts the servers in all the remote nodes. Okay, so this is in this case we have 8 remote GPUs which are located in those remote nodes. I'm just going to export those variables. It's a good thing to check if everything is, well, let me check. Okay, as I said, it's a good thing to check in order to check if everything is right. Sorry. You just need to run the device query in order to see if everything is correctly set up. In this case, we are missing the libraries. Okay, you see we have now access to 8 remote GPUs. These are the characteristics, the features of the GPUs. We have 8 remote GPUs. Okay. So now that we have access to 8 different remote GPUs, for instance, we can run you remember Fede showed you a Monte Carlo application? So for instance, we can run this Monte Carlo GPU application using 8 remote GPUs. You see, we are using 8 remote GPUs, and we have this total time, this total number of options per second. So in this case, if we do in this case, in this node, we only have 1 physical GPU, but we are using this Monte Carlo application using 8 remote GPUs, okay? So this will be one scenario in which we could take advantage of rCUDA. So what more? So we have done that. And another interesting scenario, if you remember, Fede has told you that typically we consider heterogeneous scenarios like scenarios with CPUs and GPUs, but nowadays these scenarios also have like Atom processors, ARM processors, Intel D, Power 8 processors. I mean, there are different kind of heterogeneity. So in this case, for instance, thanks to rCUDA, I could use rCUDA to access from low power nodes to GPU boxes. That will be an interesting approach. Or imagine that in your cluster you only have a Power 8 box, but it's a very powerful box. So maybe you can access even from the rest of your nodes to this box in order to accelerate applications. So this is possible to rCUDA, and we are going to show how to do this. Let me stop the So now we are going to, for instance, run a server in an x86 in a regular x86 node. So you see here we have a regular Xeon processor, okay? In this case, we have a test like A40. So we are going to run here an rCUDA server, and we are going to use it from different remote clients. Okay, we start the server, and now at first place, so we are going to access to a machine which has, it's an Atom, okay? We don't have any GPU here, okay? Any NVIDIA GPU, we have an PGA GPU, but it's not from NVIDIA. So we set up the environment in order to use rCUDA, as always. We have one remote GPU, which is in the x86 node. Connection to server failed. Sorry? Yeah, maybe. Yeah. In the server? Yeah, in the server I need to use the CUDA library path because the CUDA server is like a CUDA. Yeah. I'm going to copy and paste, and in this manner I will. I'm just going to copy and paste. This is the safe way to do it. Okay, so you see here we are accessing from an Atom node to a remote GPU located in an x86 node. So we could do the same. Instead, with an Atom, for instance, we can access an ARM. Again, we can do the same. You can see this is an ARM64. We don't have any NVIDIA GPUs here. And again, we can just configure rCUDA with one remote GPU. Hopefully we are missing something. Okay. No, I'm missing something. Yeah. Okay, so now we are accessing from an R processor to a NICs, to a regular box with the Xeon and with the K40. We could do this with all the remote GPUs in the cluster. So we are accessing from low power processors to GPU boxes. So this could be really, really useful. So what more? We have also another kind of lower power processor. For instance, we have an Intel Xeon, an Intel D, which is also a low power processor. We here don't have any NVIDIA GPU. So again, we can configure rCUDA. Okay, and again, we are using the same GPU box from different heterogeneous platforms, and we are sharing that GPU. Okay, so as I have already mentioned, another interesting thing will be, imagine we have access to a Power 8 box, which are really expensive, and I only have one. This is the case of our cluster. So we have here a Power 8 box, which has two P100 GPUs. Okay, we have here two Tesla P100, but we only have one in our cluster. So maybe we can use rCUDA to share these P100s in one Power 8 box among all the different nodes which are in an x86 box or whatever. So again, as always, we just need to start the server here once. And now that the server is started, and now we are going to move, for instance, to a box with a regular Intel Xeon. This box have two Tesla one Tesla K20, one Tesla K40, but it doesn't have any Tesla P100. So we are going to configure this now in order to use the remote box in the Power 8 system. So in this case, we are telling, okay, we have two GPUs. One is, both of them are in a node called MLXP1. One is the GPU 0, and the other one is the GPU 1. Okay, so you see now we are accessing to this remote GPUs to this remote node with the 2P100. So we are sharing this powerful box among all the nodes on the cluster. So at the end, what we have seen here is that we have a lot of flexibility. We can now use the GPUs, and we can share among all the cluster. We can share among ARM architectures. We can share among Power 8 and x86 architecture. I mean, what we have here is flexibility, and we can just use the power of the GPUs among all the nodes of the cluster without limitations. So with this, this is the end of my presentation. Thank you very much for your attention, and if you have any questions.